All right, well, welcome everyone to Calculating Upfront Embodied Energy in Buildings. This course is approved for 1 hour in continuing education units among many Con Ed, as well as AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. This course is brought to you by the nonprofit The Green Home Institute. I'll be your moderator today. My name is Brett Little. I'm the program manager here, and our mission is to empower people to make healthier and more sustainable choices in the places we live. So we've gotten really good and we're getting a lot better, and it's getting easier now to make our buildings net zero, zero carbon, operational wise as far as our energy use goes. The grid is getting clean, we're going all electric. Still got some work to do, but we're getting much better at it. But the question now is, what is next? And I believe that's going to be going after the embodied carbon or the upfront carbon or embodied energy, many different names, in the materials that we're actually specifying within our buildings. And so that's what we're going to be talking about. Before we get to that, a huge thanks to our top tier sponsor, Mitsubishi Electric. Mitsubishi provides ductless mini splits that can now be hidden in many different ways to meet your client's needs, with ducted systems that can go in as well. They can be retrofitted right into place of an existing furnace or multifamily project. Each room of a house has personalized comfort while still being all electric, and has energy efficiency for your clients with different needs, only to heat and cool rooms as you need it. Take it from me, I just got through one of the coldest winters here in February. We had one of these in. The H2i plus hyperheating heat pump technology is what got me through it. The outdoor units produce 100% heating capacity all the way down to -5 degrees, giving a warm and comfortable environment, even in sub-zero temperatures. The dual barrier coating prevents dust and dirt from accumulating on the inner surface of these heat pumps, keeping the indoor unit clean year-round. A cleaner coil means easier maintenance and higher efficiency for your heat pump. Dry mode can be used as well when not as much cooling is needed to remove that excess humidity. And they also have a sensor to detect if there's anyone in the space and how much heating and cooling really needs to be going on. The diamond contractors are there to help you through to select your best product. So make sure to check out those folks to help you out. And for multifamily and commercial, they have variable refrigerant systems that can now be used for energy recovery and heat and cool simultaneously as needed. Check them out over at Mitsubishi Comfort today. And thanks to our second tier sponsor, T-Stud. Are you ready to go naked behind the walls? The Bare Naked T-Stud is similar to the R19 stud, except without the foam core. And because 39% of all builders use blown-in fiberglass, cellulose, mineral, hemp, you name it, you can fill it with whatever insulation you want and stop that thermal bridging without the extra hassle of the exterior insulation. Check them out over at tstud.com. So I am so excited to hand it off to our speaker here, Stacy Smedley with Building Transparency. Stacy has a Bachelor's of Arts in Architecture from the University of Washington and over 18 years of architecture and construction professional experience. Her resume includes the first ever Lead for Homes Platinum certified project in Washington State, as well as the first project in the world to be certified under the Living Building version 2 standard. As the sustainability director at Skanska, Stacy leads sustainable initiatives and is considered a subject matter expert in LEED, Living Building Challenge, carbon emissions associated with buildings and construction. So Stacy, I am going to turn it over to you now, and welcome. Please take it away.
Thanks, Brett. I'm happy to be here today. I'm going to go ahead and start sharing my screen when I get to the right one. There we go. You should be able to see my PowerPoint now?
Yep.
Alrighty, I'll go into slide mode. So I'm really excited to be here today to share what we've been working on at Skanska, but also what I'm now working on as executive director of a nonprofit called Building Transparency, and that's really supporting embodied carbon reduction through digital data transparency and the embodied carbon and construction calculator, or the EC3 tool as it's known to most. And really to start this off, I wanted to just kind of ground everyone in a new graph that I've been using a lot, which is this pie chart of greenhouse gas emissions, not by sector, which is what I think we've seen a lot of to date, which is the percentage of emissions associated with buildings, and really dig into that manufacturing emissions, supply chain emissions pie to walk through where building materials fit in. So again, buildings we know are about 40% of total greenhouse gas emissions globally. About 10 to 11% is considered potentially embodied carbon emissions of the materials. But if we start to look at manufacturing, it puts it in another kind of lens for us, where manufacturing emissions are about 31% of greenhouse gas emissions globally. And if we look at what that breaks into in terms of materials, cement and iron and steel make up a large component of that pie, as well as what would be considered other, which is all the other building materials that we talk about are in that other 32%. So when we look at manufacturing, it's a large chunk. When we look at the building materials that are part of that manufacturing emissions pie, the things that we build our buildings with do comprise a large portion of that. So we need to be considering it. The other reason we need to be considering the total emissions of our buildings, including the embodied carbon, are really because we are now understanding the impacts and the scale of what we're building globally. So over the next 35 years, this is a slide that Architecture 2030 has made that's shared broadly now. We know that we're building trillions of square feet of new and rebuilt buildings, both residential and commercial, across the world. And that equates to about a New York City every month that we're constructing in various forms and places. If we're building that much stuff, we really need to understand the emissions associated with not just operating those buildings once they're built, but also constructing those buildings. And when we dig into that, what we find is that if you look at just a global average energy grid and material emissions, that a building's embodied carbon can be half, if not more, in many cases now is what we're finding, of the total carbon emissions pie to a 2050 horizon, which is really when we have to get to zero. The other thing about embodied carbon that is unique to operational carbon that this graph shows is that once you emit it in the manufacturing and installation of your building materials, that upfront carbon, it's in the atmosphere and you can't take it back. With operational energy, of course, the building accumulates that over time. We need to be efficient to start with, and then we can, of course, retrofit and optimize. So there's another chance for us to at least make up the emissions or do better. So embodied carbon, those upfront choices are keenly important because once you've made them, you can't change them. Just another slide that I use that's more of a cartoon and visual to really describe embodied carbon versus operational carbon. These two together are really whole building carbon. It's a term that's come out recently. Of course, operational carbon is the consumption of the buildings once they turn on the lights and the systems and are operating, all the energy consumption associated with all of the systems in the building. Embodied carbon is really, if you're looking at whole embodied carbon, everything before that. So how we extract materials, how we move them to a manufacturing facility, how we manufacture them into products, how we transfer those products to a construction site, how we install those products into a building or an infrastructure project, and then even how we reuse or maintain those products during their life. How many times are we replacing things, all the way to what are we doing at the end of the project's life, and how are we demolishing this building, building it for hopefully deconstruction, and what happens to those materials? Are they going back into new materials to negate the need for raw materials, or are they going to a landfill at their end of life? So it's a lot, but I try to put it in these graphics because at least we can think about it visually. One of the things that's exciting to me right now, I've been working on this now for a handful of years, and even in the past 5, there's been a complete change in terms of who understands what we're talking about when we say embodied carbon and who's thinking about it or building it into their project requirements, all the way from residential to commercial to infrastructure, and all the way from city county policy to national policy. So I feel like we're at a tipping point when it comes to embodied carbon understanding, and now we need the positive influence of that to reduce emissions and negate the negative tipping points of climate change. Some examples of this tipping point for me come from what we're seeing in both the private and the public sectors from what I would call policy perspective. So on the private side, this is where I think we're leading a little bit ahead of public policy and even ahead of other global markets here in the US. We have companies based in the US like Microsoft and Amazon that are very large, doing a whole bunch of construction, building things all the way from commercial office space to data centers to warehouses. Now talking about scope 3 emissions, which is where our embodied carbon emissions live and their kind of accounting philosophies. If you look at this slide from Microsoft, when they started doing the math and they started looking at it through the building lens, and then looking at it for all the other things that they make, the scope 3 emissions of what they're making and their supply chain of all of those things that they need to make with, including buildings, just is very large compared to the other two. So it's 12 million metric tons for that scope 3 where their buildings live, and only 4.1 metric tons for everything else in terms of, you know, the operations of their facilities and the transportation of their employees. So it's becoming really important to these companies to understand these emissions. They're making zero carbon targets that include those scope 3 emissions. Amazon's doing the same thing, saying they're going to get to zero by 2040. And so these companies now are leading and saying, I want our architecture, engineering, contractor partners to understand this, to track this, to push the supply chain to reduce. We're also seeing this on the policy side when it comes to public policy. The Carbon Leadership Forum has a great policy toolkit on their website that looks through this map, or looks through this policy and where it's popping up, what it's asking for. So it's a great resource. If you just go to the Carbon Leadership Forum website, you can just Google it and find this policy primer. But what you'll see here is that there's policy at the state level right now popping up, looking at buy clean procurement, which is looking at environmental product declarations, which I'll explain, and the supply chain embodied carbon of buildings. So that same kind of policy, it's been implemented in California for some materials, is now being proposed and studied in various other states in different ways, but it is something that we're seeing spread at the state level. All the way down to the county level here in Seattle, where I sit, King County's Climate Action Plan has now built in the requirements and requests for environmental product declarations for concrete, using the EC3 tool to eventually require a maximum carbon content or global warming potential for mixes. So again, state and county, and then all the way up to federal policy. So we're also seeing policy at the federal level. It's already out and published on the House side. There's the House Clean Futures Act that has federal buy clean procurement requirements that engage in environmental product declarations for various materials, and then would set thresholds and even a climate star, you know, label similar to Energy Star for the best performers and the bottom kind of lowest carbon thresholds for different materials. The Senate's also putting together a bill right now that would be complementary. And then also, folks like Bill Gates are writing books. So in his new climate book, he talks about specifically concrete and steel and how we decarbonize those industries, which is vitally important. And that's where a lot of investment from large philanthropists like Bill Gates are now going. And what I think is also really interesting, before I get into the nuts and bolts of how we do this as an industry, is just how it's being talked about globally from various types of sources. You know, I think in the past, sustainability in the built environment can be seen as a negative. Take this away, don't use this. When it comes to what's happening around decarbonizing building materials, it's all positive. It's investment, innovation, getting the carbon out. How do we make these materials better? So I also think there's a positive approach that's being taken to some of this that's really, really hopeful. So I say all this, and I talk about all these things, and I guess to back up, this was really me about 5 years ago when I was trying to dig into carbon emissions of construction materials at Skanska. So I was learning about it, I was understanding the impacts, I was seeing where the emissions were, and then my question was, where do I get the data I need to actually make informed decisions to reduce this? And that really started again once I knew where the impacts were and that I wanted to look at embodied carbon. What really are these stages that we're talking about? So this is just, again, in that same kind of cartoon form, going from operational versus embodied, and now digging into that embodied carbon that I mentioned briefly. There are these different stages of embodied carbon. It starts with the product stage, which is where EC3 focuses, but there's also all these other stages. So upfront carbon is really the carbon emissions associated with everything till you turn the light switches on. So how do I make the materials? How do we get them to a project site and use equipment to install them? That really is the upfront carbon, which is the title of the presentation today. The use stage is stage B, which is, again, if I'm building a building, how many times am I gonna have to replace the roof or the carpet? And I need to build in those replacement cycles and that quantity of new material over the course of the life into a calculation. And then end of life is really the construction or the deconstruction stage, which is hopefully deconstruction, sometimes demolition, where you're thinking about what the emissions associated with demolishing that building are, what are the emissions associated with disposing of those materials. Is there a credit that can be taken for those materials going back into new materials, or for wood, is it being turned into mulch or being burnt as fuel? Those types of decisions and impacts. So that's really whole carbon on the embodied carbon side. Again, what we found in our research at Skanska, once I had gone through the process of understanding these emissions and tracking it, is that this A1 to A3 product stage is typically 80% plus of the overall embodied carbon impacts. It's also the thing that you can't make choices or change, later on in terms of reuse of products during the use stage or end of life. So if we focus on this upfront carbon stage, what we then found is this product stage versus the construction process stage. If we look at just that A1 to A3 versus A4 to A5, A1 to A3 was about 95% of this upfront carbon. So again, whittling it down to where the largest impact was, and where once you made a choice, you couldn't change it. EC3 and Skanska started really keenly focusing in on how do we attack this product stage carbon emission bucket. So getting into EC3, EC3 is a free, open access, transparent, hopefully easy to use, industry-led, supply chain focused calculator that was co-conceived of by myself at Skanska and Phil Northcott at a software development company called Sea Change Labs. And the hope was to come up with a way to democratize all of this carbon emissions data of products into a database that anyone could use to make informed specification and procurement decisions, looking at carbon as one of the decision-making factors. So another layer of all of this is how we do the accounting of it, and I just want to always make clear that there is whole building lifecycle assessment that does look at all of those stages that we just talked about of carbon, and uses average emissions factors to give you really good kind of directional data for systems level choices. So tools like Tally and OneClick and Athena allow you during the design phase, before you know how big your building is going to be, what your systems might be, to input that information about if I do concrete and steel versus timber and steel, or if I use this envelope system with this insulation versus that one, which one's better from a whole carbon perspective. And you really want to look at it through that lens, because that's where you can make comparisons with average data. Once you know I'm building my building, it's going to be steel and timber, and it's going to have this envelope system, that's when you can actually dig into the specification and procurement using EC3, starting in the construction documents phase. So this is where you're a specifier, an architecture firm, or an architect looking at the materiality of your choices, and you know you're going to have gypsum board and carpet tiles, and you know you need type X, and you need the carpet tile to be this color, and I have these three choices. You can go into EC3 and really say, if I have these three choices, I know the suppliers, which one is the lower carbon option that meets my requirements, specify that one. And then during procurement, being able to actually account for it and say that, yes, this is what I installed using our database of product EPDs. So do whole building LCA to make directional systems choices and optimize your building from a size and system perspective. Use EC3 to specify and procure the lowest carbon options. And then at the end of the day, realize an embodied carbon accounting for your project. EC3 was informed by a whole bunch of people across industry. So once the tool was incubated at or conceived and kind of seed funded at Skanska with some help from Microsoft, it was then turned over to the Carbon Leadership Forum and incubated. And during that time frame, all of the folks on the screen were actually involved in what it would look like, how it would function, and what it needed to do before it was launched. So it was an industry-led effort, and we're really proud of how many perspectives and voices we had in that process. Once it was launched, it was turned over to the newly established nonprofit Building Transparency. I am currently the acting executive director with the support of Skanska, and we have a board that's largely the large tech companies that I alluded to in terms of who's really looking at this carbon emissions at kind of a large scale. In Building Transparency, its mission is to create and provide the open access data and tools necessary to enable the action we need at the speed we need to address embodied carbon's role in climate change. Our current funders at Building Transparency, there are some funders that have stayed on and partners that have stayed on from the incubation phase. We continue to get new funders and partners. Breakthrough Energy is our large philanthropic funder with the support of Gates. We also have a lot of large owners and contractors, architects, engineers, again, trying to have a good lens from all the different potential users of the tool, as well as industry manufacturing partners that are there to help support the building of their categories in the tool and really want to see this information open and free as they're investing in it and creating it. Our newest one that I didn't put on here is Lowhanging from a cement and concrete perspective. So projects we're working on, I'm going to focus on EC3 today, but I feel like embodied carbon is kind of like an onion, and we're peeling back these layers and our eyes might tear up because it's hard sometimes. But there's a lot more that we've found that we need to do as a nonprofit with that mission to really provide the data that is necessary. So EC3 tool is our main focus. We're also working on a whole bunch of other things that support EC3 in the data, starting with Open EPD, which is a standard for digital format for environmental product declarations, a database of free open access lifecycle assessment data for building materials to help inform those whole building lifecycle assessment tools, but also EPDs, and then policy and certification support. I'll talk about the LEED low carbon procurement credit a little bit as we demo the tool. There's also groups that we're now establishing across different sectors of industry. So we have Materials Carbon Action Network, that is a group of manufacturers talking about embodied carbon with programming. We now have a newly formed Owners Carbon Action Network with over 18 owners at various scales across different industries. And then we also have resources that we're developing that are free and downloadable from our website that help you actually figure out how to specify and request some things. You may hear some dog barking and child activity in the background, so I apologize if that happens. So to dig into EC3, it really is a carbon estimating tool and a specification and procurement tool. So there are two components to it that I'll get into, but really if you think about it through the lens of a carbon estimator, we're taking material quantities out of construction estimates, BIM or tally, and multiplying it by a kilogram of CO2 per unit of material, very similar to how we take quantities and multiply that by a cost per unit for cost estimating. The information on the carbon content is coming from our database of environmental product declarations. That database allows you to find and compare materials without a building level estimate if you like, to inform specs, but it also feeds into that carbon estimator tool where you can actually get a good lens of your building's potential carbon in this product stage and make smart decisions to see how well you've done against what's possible. And just to ground everyone, I've talked about EPDs a lot and the slides to this point, and really just to ground everyone in what an EPD is. It is a third-party verified document that is invested in by the manufacturer. They have an LCA expert come in and do an LCA lifecycle assessment of their product and their plant with all of the inputs of the materials that go into it and their unit process emissions, plant emissions of how those materials are made and what emissions come at the plant level for the manufacturing. That LCA report then gets verified by a third-party verified program operator. It has to follow ISO standards and certain product category rules. Basically what comes out currently is a PDF document in various formats depending on who the program operator is or the manufacturer is. And really the important key piece of information is this little table that might be on page 8 or 10 or 12 that's going to give you the carbon content or kilogram of CO2 equivalent per declared unit of material. And I always may say it's similar to a nutrition label on a piece of food where you've got a carbohydrate per serving size. So if we can get to this information in these documents, we can then digitize this information into a database and provide it to be able to do that math. And that's what EC3 is currently doing. We've currently digitized about 40,000 EPDs. A lot of those are concrete because we've got a digital integration already for concrete EPDs. On the material input side, currently there's kind of 3 ways to get information into the tool and the project planner, which I'll show in more detail. One is through construction estimates, where if you've got an estimate in unit format or master format, you can very easily just hand input the information into that same kind of organized format in the building planner and then assign your material emissions to that. There's also an import from BIM 360 and a beta plugin for Revit directly right now that we're planning on releasing publicly. The BIM 360 import's already public. and then a tally export. So if you're using tally in Revit to do whole building lifecycle assessment, you can export your tally bill of materials and quantities to EC3, and then start doing the EPD selection and sorting as the next step. I'm going to go through some screenshots of EC3 first to talk about this, and then I'm actually going to go in and do a demo. It's always good to see things a couple times, and I go kind of quickly. So starting with when you're at the landing page of EC3, you're going to see some data points that tell you how many EPDs we have in the system across what categories that are currently included. And you're going to be able on the left to actually see find and compare materials by material category to dig into your searches. You'll see here there's a lot of categories in pilot. That means that they're not public yet, but they are populated with EPDs, and we're working through the process of trying to engage with the industry first before we release them, to let them know that we're going to be releasing their EPDs to public, as well as think about the filtering and things that we do. Really, this is a user-led tool, so as EPDs are imported, categories grow, and then we can then actually release those categories once they're populated. To do a search, you can click on something like concrete and get to ready mix. You can then filter by a location or a group of locations if you're looking for some regional data. You can click search, and it will return the number of samples that meet your search tips. These little blue things right here are the search tips that are reminding you what your current filters are. You can go farther down into filtering, things like compressive strength if you know it for mixes. It's going to give you a box plot on the upper right that's going to tell you the complete range of kilograms of CO2 per unit of material that we've pulled out of those 2,000 plus EPDs. And if I open up what that box plot is telling you, again, this is telling you these are mixed results from this 2,000 EPDs that met your criteria. There's the highest return result, which is 1,160 kilograms of CO2 per cubic yard. The 80th percentile is, again, the 80th percentile of the result. We call that the conservative estimate. So that's saying that if you don't try to do anything, you probably aren't going to be worse than that, but you could be that bad. Throwing away the top 20 as outliers. Those could be something where there's a high cement contact because it had to get to strength for 3 days or something like that. The 20th percentile is the 20th percentile of the results, so they're still 20% below. We call that the achievable target. It's a good place to aim. It's still giving you a buffer in terms of not saying that you're going to get down all the way down to 56, which might be, again, a really crazy mix that someone made for a very particular purpose with very little cement, for instance. Again, so that green bar is the 20th to the 80th, and really where directionally you can focus your eyes. It's 60% of the data with some outliers above and below. There's also a CLF baseline that's been established by the Carbon Leadership Forum for the public categories in EC3 to date. That CLF baseline is supposed to be a high conservative estimate, basically to incentivize disclosure and say, start your reductions from here. You can set reductions that are very small, or you can set very big reductions, but at least it's against a static line. And those baselines are on the Carbon Leadership Forum website, also available for review within EC3. Once you have also done your search, there's a compare button that you can click above the manufacturers, where you can actually look at the manufacturer level, who has EPDs that meet your search requirements, how many do they have, and directionally, how are they performing. So this is looking at 3 suppliers. You can see here, this is a Washington search, and this is November of 2020. Here's where all of their 5,000 PSI mixes are coming in. They all have almost 100 or more EPDs. And really, I think the philosophy behind this that I'll show kind of our proof of concept in a minute is that as we have these comparisons start to develop and these baselines set, as people use this and request lower carbon mixes, those numbers and those baselines will hopefully all trend downward, and we can actually make the baselines lower, we can make the reductions bigger, and the carbon emissions of all these materials will just generally go down as this information is used. Again, you can go further into the details, or you can actually search by manufacturer and even a plant to get to a list of mixes just from the plant that you know you're going to come be looking at. If you know 3 mixes meet your criteria, you could even pick those 3 mixes, start comparing the mixes, and know that that 4C 44438 mix is the one that you should probably procure if you can, if they all 3 meet your requirements. The other thing that we do in the tool that is important and required by ISO to do comparisons is provide uncertainty around that number that's declared in an EPD. This is something I didn't realize was necessary or important when I started looking at the data and saying I had this declared number, and if it was 102 from this supplier and 100 from this one, I should choose the 100. And that's how I thought I could use the data. When you start digging into the data in EPDs, you'll find that there are different levels of specificity. And we need to have some uncertainty around that declared number to account for the fact that they aren't right now red apple to red apple. They might be green apple to red apple, but directionally there's uncertainty to think about. So what we've done is actually look at EPDs and classify them if they're manufacturer specific, plant specific, product specific, then how supply chain specific they are in terms of all the underlying data for the different ingredients. The more we know, the less uncertainty there is. The next part of the tool is the plan and compare buildings function, where you can import a building project from BIM 360 or just start one from scratch. Again, as I mentioned, this is where you can actually type in, and I'll do this live after we talk through the slides, type in your description of your product if you want to use an estimate, type in your quantity of material in the unit that it's declared in, and then do those collection of searches. Right now, you'll see this was I went into the planner or the material function. I searched by ready mix within a 100-mile radius of my project now for 5,000 PSI mixes, and that's what's going to be attached to my quantity now, or all that box plot of data from just my particular search for my project. So there I am doing my search. As I mentioned, within 100 miles of my site, I have a good collection because this project is in California. I'm going to use this collection of data to set, what's possible for my project from a concrete perspective. Once you've done that for all of your products, you're going to get the results where you can see that conservative and achievable for your project based on that supply chain specific data from EPDs for all the materials that you put in. It's going to give you a total in millions of kilograms, and then also an intensity, which is kilograms of CO2 per square foot or square meter. So the realized will default to the conservative number until you start selecting EPDs, once you know what you built with. You can also see this information in a group of charts where you click the summary chart button. You'll see here we've got the charts across the different kind of filtering you can do, as well as lead charts. The lead chart ties directly to what's required for the lead pilot credit, which is looking at the public categories in EC3. If you create a building in EC3 and disclose, you get 1 pilot credit point. If you actually select the EPDs that you use and show a 30% reduction or more against the baselines, you get two innovation credits right now. And these bar charts and exports that we have, they're labeled lead, they meet that credit requirement. If I look at the Sankey diagram for a project, this is really what you can use when you first input your data and you're trying to understand where your upfront carbon impacts are for your project, as well as where reduction potential is based on your searches. The Sankey diagram is showing you the relative impacts on the left of each material category. So there's my ready mix versus my rebar versus my carpet versus my ceilings, etc. So this is a small project that actually had my son do. It's an underground layer for our dog Shuck. But if you look at this, what you're seeing is that the ready mix concrete is the largest impact. And there's a pretty good reduction potential from that 80th to 20th percentile for all those EPDs available in my market. So that's saying that I could potentially reduce the carbon content of the ready mix by that white bar. This rolls it up to different components of your building, all the way up to the overall building, taking all of those different materials. In this case, we used the baseline to show that the starting point, what reduction is possible to the 20th percentile achievable target across all those different categories. We're seeing owners now use this data to set reduction targets for their projects at the beginning or during SD or DD, and then tracking it through construction to see what actual savings they make. So I'm going to pretend now that I know the EPD that I use, the mix that I use. So I'm going to go back into search. I'm going to go search for that mix and select it. It will show me how my selected mix performed against the whole collection of potential EPDs in my market or for my product or performance filter. And then if I go back to the summary charts, what you're going to see is there's now a realized line that pops up across all these categories over to the building. So it's showing me that I actually almost got to my target of 51%. You can also look at this in the bar chart. This is what is used for the lead credit. It's going to give you the baseline from the CLF, the potential real achievable savings of the 20th percentile and how you did across all the different categories that were included. Now I'm actually going to go into the tool and do a little bit of a live demo. I let Brett know that if you have questions as I do this, I'm happy to answer them as I go. I've seen the chat box blinking over in the corner, so I do go through this fast, but I'm going to basically do what I just showed you in slides live again, so you can see how it actually works when you're in there clicking buttons. But as I do this, if questions come up on a screen, Brett, I'm more than happy to take them if you pipe into the presentation.
There was a question now, and maybe you can just say, hey, I'm going to cover that, but can you take one real quick?
Yeah.
So obviously, if we are reusing buildings or homes, I would assume that salvage or reused material has a zero carbon, zero embodied number to it. So the question really is, is that true? And then how do you compare using something new versus salvage? Like, what are your thoughts there?
Yeah, so we've seen, you're right, it would have a zero or very nominal impact based on, transportation emissions and those things I talked about being such a small percentage of things generally. And then the tool what we've seen people do is create a baseline building. So if it was a house, can you create a baseline house where it's got the amount of wood and the amount of concrete slab and windows and all the things that you would typically do from ground up. And you can create a project that just accounts for what you actually did. So if you reuse the wood and you reused some windows, you wouldn't put that into your actual building, and you could compare the two. So you'd be like, okay, if I'd done everything from ground up new, it would have been this much. I only did this much new, and you can see that delta between the two. So it really gets into creating a benchmark project, whether it's a house or a commercial office building or whatever it might be.
So even if the wood studs or windows, you weren't using any new ones, you could put it, they would still be accounted for in the tool, right? It would still show up as a
line item. You could put in, the way that we've seen people do it, if they want to just show that they've included it in their estimate, you would just put a zero quantity in the line item and a zero carbon content would pop up.
Right.
For instance. Yeah.
Okay. Thank you.
Yeah. So to log in and register, you just need to go to buildingtransparency.org. It is a free tool, so you can just register for free and gain access. While you're registering, if I just go to that screen, you can set your email and password and the name that's going to be displayed to whatever you like. If you are at a company and you're using your professional email address, if you put in your employer and your profession, when you log in, you'll immediately become a professional user. If you don't, you'll be a private user. The only difference there is that the professional users, because they're tied to a company, can do things like sharing. We have to make sure you're doing it from a professional. It's based on CPDR requirements, which I know enough about to be dangerous, but that's just one nuance that some people get questions about, just in terms of why am I private versus professional. You can still search and sort and everything. You just wouldn't be able to potentially even share a project, which I'll show you using email addresses. So that's just to sign in. If I go back to the home page, once you've logged in, you can just sign in from the site. I, of course, have it bookmarked now, or I can just get to the login pretty quickly. So I'm just going to go ahead and sign in. And what you're going to see here on the landing page is that set of kind of data points that I mentioned briefly, where you can see, where do we have EPDs? How many do we have? These are for non-concretes. You can see where we've gone global. So we're now pulling on EPDs that exist across the globe, which is exciting. You'll also see if I click on concretes that we're way ahead here in the US because we have done a digital EPD with the major LCA providers for concrete EPDs. So now concrete suppliers can do on-demand EPDs where they just type in their mixed designs. All of the inputs have been verified and it spits out an EPD directly into our tool. So we're trying to actually spread this to other places now, which is exciting. To be leading on something in sustainability in the US. You can also see where we are from a US perspective. The one thing I would mention is that for non-concretes, this gets into things like carpet or steel, where we have pretty good coverage for the major suppliers right now. And you're going to see that, places like Georgia, where we have carpet tiles coming from and the main mills for steel pop up. For concretes, even though we have so many EPDs because we can do mixed specific designs, you can see that there's just these pockets, and concrete is regional, so we really need to get to more suppliers, the major suppliers in more markets, investing and disclosing. But in places where we have had that investment from one, the others get on board because of the competition, and we start to get these really, really robust data sets. And this is spreading actually pretty quickly. Every time I look at this, I feel like there's more counties that are popping up with data. We can get more into that and how you request that data a little bit later, probably. Then again, just what categories we include. I mentioned the public versus private. So if you look at this as a public user, it's going to look a little bit less, which always makes me sad. But we are trying to push out the new categories as fast as we can. This is, again, how many product specific versus industry average EPDs do we have? Industry average EPDs are where a whole bunch of suppliers have given data to create one average number for a product category. So they're useful to get a kind of a proxy, but those product specific ones are the ones that you need to actually know what you actually install from an emissions standpoint. You can even get to the point of plants versus manufacturers. So we have 401 concrete plants and 58 manufacturers. There are about 2,000 manufacturers of concrete in the US. So that's where the work really comes in. For steel, you can see we have 79 manufacturers and 151 plants, with about 70% of all the steel plants in the US covered right now. So every category is a little different in terms of coverage. For wood, we do have some. It would be nice to get more. I know it gets really complex when it comes to things like rough carpentry and how wood gets harvested and then put into fabrication and then stockpiled and purchased. So we're trying to help the timber industry a little bit there too in terms of how we can get to the level of data we need without really hurting how they supply wood. If I dig into the tools used again, like I mentioned, that find and compare materials category is how you can get to the different categories included. I think I showed concrete when we did it in the slides, so I can go to steel in this case. Over on the left, and I can click on rebar, for instance. You'll see it opens up in this tree too. So if you like the tree better, you can use the tree to get to whatever you'd like to search. If I click on next, that's where I get to the performance parameters for rebar. So it looks different than the concrete one, which it should. I can do things like I just mentioned, where I can type in what I want to get to from a filtering standpoint. It also shows it in the tree for you. So if I pick Washington and Oregon, for instance, know that I'm building a project that could procure from those two places and click OK. Now I've got my Washington, Oregon search parameters. I'm just going to search by that. I don't know what my potential strength is going to be. There's the box plot of the current set of data. You can see it's getting lower. The CLF baseline might need to get lower in the next round. If I scroll down, you're going to see that we have 10 product EPDs for rebar. Here's the manufacturer and the plant it's coming from, and the different spread of who we have in the tool. So it's a pretty good collection of rebar suppliers. You can click on compare and start to compare them from a manufacturer perspective. You see Cascade's got 2 EPDs, one for each of their plant. There's the uncertainty I mentioned. It gets into how specific the data is in the EPD, but directionally even you can see that if you pick from any of these guys, because they're likely on a pretty clean grid and using high recycled content, that you're doing pretty well, with Nucor being the lowest right now. So that's how you could use the data for another material category. I'll do one more, just at the kind of interior level. If I go down to finishes and I go down to carpet, and there's the carpet searches. I'm going to take off my my filters now and just put in the US. My search. Now I'm doing a search of all carpet in the US. I'm going to say I know that I'm using tiles, and I'm going to click search. There's again my box plot. If I come down, you'll see that here again are all the different suppliers of carpet, all the way over to the name of the and description of the product. So if you knew your product, you could start to filter for that. Click compare over the manufacturer. Get to that same comparison at the manufacturer level for carpet tiles of who has how many and how they're doing directionally. And then be able to do something like, if I want to pick products, I can start to compare that at the product level too. So that's how that works. If you want to look at more details for one EPD, you can do things like select it here and scroll up and see how it's comparing to the whole category in the box plot. You can click on details to start to see more information that we pulled out of the EPD, and you can even open the digital EPD to get into the details. It'll open up in a new window, but it'll show you our digital EPD format and everything that we've pulled or digitized out of that document. So again, how specific it is, what other stuff has the manufacturer provided from a performance standpoint, all the way down to things like all the other impacts. So even though EC3 is focused on this A1 to A3 global warming potential, which is the required impact, if there are more disclosed, they'll be in the digital EPD, even all the way down to plant location and who verified the data. You can also download the PDF document directly from this digital EPD as well, right here. Okay, so that's the find and compare materials function. Going back into plan and compare buildings, this is where you'll have buildings under my buildings. So those are any buildings you create. You have a couple of templates. We're building a residential template right now. There's buildings that are shared with you. I'll show how that works. And then I'm just going to the public buildings. This is something that you could see. So I think if I go into one of our demo buildings, what you're going to see is that it's got, you know, an address and a construction start date and a location. We've gone down and input all the things. And so this is just, you know, another example of a project that's been put into the tool that you can go reference. I'll show a couple of the things that allude to what I was talking about for comparisons. So this is where you've got kind of this folder structure. So you can create a folder structure for a particular project, have a baseline building within that structure, even break up the building into different components if you wanted different models for things like structure, interiors, and enclosure, and then do comparisons. So here I have 3 different buildings. If I know I've done all the work in the project planner to have the data incorporated, click on those 3 and click compare. And there it's going to show me those 3 buildings next to each other. From a kilogram of CO2 per square foot perspective. You can view this by category to see where the impacts were for the different materials that were included, and really start to either create a benchmarking database for a bunch of different projects of the same type and see how they're doing. Is there kind of a standard benchmark or level that you're getting to? But as well as, you know, if you created a baseline building and then had your actual, you could see the difference based on, here's if I started from scratch and built a new project, here's what I actually included from a materials perspective. How much did I save by reusing some of those products and not having to account for them? I think the last thing I'll show is just the other functions in the tool. If you are doing this and you've found an EPD we don't have, so maybe there's a cool new product that created an EPD for something like a new insulation type or something, you can actually add an EPD to EC3 yourself and just import the PDF. It will show you where it is in the system. If we already have it, it will tell you we've already digitized it. But that is a way to grow the database. If you find something that we don't include yet, you can upload it yourself. There's also the Manage Data tab where you can actually just get to the whole list of EPDs without doing it through the category searches. So this is something where if you're a manufacturer and you just want to come in and see what EPDs we have, this is the entire database. I could search Shaw's popping up first. So if I just filter for Shaw, it'll give me all of Shaw's EPDs right here with the way to actually go open them without having to go through the find and compare materials function. So this is just another way to query the database using a whole bunch of different filters. There's also ways to create user groups. If you've got your building function, I'm just going to go back because I didn't show this to you. I need to go to my building. I'll go to my son's project again. But if I wanted to, it's telling me it's shared because I already shared this project. But if I click on this button, there's the ability for me to find other people. Brett, I don't know if you have a login yet, but I'm putting you in. I could share this project with Brett and give him read, write, or manage access to it. So there can be multiple people working on the project, similar to Google Docs. I will tell you if someone else is in the project working on it. But ability to actually use the sharing function there. The last thing I'll show you is just how to get an EPD. So this is where maybe you have a material that you use that doesn't have one yet and you'd like to be able to help the manufacturer. This how to get an EPD tab. It's going to be a guide of how to get an EPD. It's going to walk through kind of all the steps of what they are and why and how. But if you are trying to help a manufacturer or you are a manufacturer, you can click on product EPDs, get to a category, say I'm a manufacturer of wood, plywood. If I click next on this screen under how to get an EPD, it's going to tell me which program operators currently have provided EPDs for your category, how many they've done, and then kind of locations of their EPDs, so you can actually get to the right potential resource for that manufacturer to create their document and invest in an EPD. The last thing down here, just for those that really want to dig into methodology, we do include the baselines methodology here, and you can link to their report as well back to the CLF. That's a place where you can actually reference and start to see how those baselines were established and access the document that gives them to you. With that, I just have a couple more slides before we can open up to kind of deep Q&A. The first is just the current steps that we're seeing in this process. So we now have a bunch of pilot partners and users that are doing this. So the first is if a manufacturer or product doesn't have an EPD, ask for one. I mentioned that from the homepage of Building Transparency, you can go to resources and documents and download some request letters that we put out for people to use that gives some of the requirements and helps frame why we're asking for these documents. If they do have EPDs, specify them. So use the tool to really pick the lowest basis of design carbon option that you can and help that guide your specifications and what you build with and design with. And then make sure that request gets into the bid documents. For larger projects, this is important for a company like Skanska to build this into the documents going out to for this instance, concrete suppliers, requesting EPDs. If you don't have one, will you get one? And that you'll provide mix specific EPDs with your cost bid. When this happens, we can then do this kind of bid leveling where we actually can put the carbon content for all the different mixes or products next to each other from the suppliers that have bid, and understand that the low carbon bidder is X, and look at that next to the cost. And in every case to date, in most material categories, the low carbon option from a bidding perspective has been the low cost option at the same time. So it's been pretty exciting to see. Again, once you've done that, you can then track your realized savings in EC3 by selecting the EPDs for your products and get to that realized savings, that realized carbon content for your project. So again, just another way to think about this, if we look at the trends and the policies that are coming out, requiring EPDs, utilizing EC3 to find them, make sure they're under a target or a kilogram of CO2 if that's established, and then require the project teams to submit the data during construction so that you can actually see what your realized carbon content was. The tipping point stuff, I need to update this, Brett, because this is, I think I gave this to you and now we're at like 14,000 plus users. So again, this just continues to grow and it's very exciting to watch. And it's fun to see that it's a mixture of AECO research manufacturers that are engaging with the tool, which is what we hoped for. There's over 28,000 searches of the concrete category in a 6-month period. So this adoption, the fact that the data is being looked at, helps us make the case for the suppliers to provide the data, but also to reduce the carbon content of what they're doing. And then from a building perspective, I think there's over 2,000 building projects now that are in EC3 that as they're finished and the realized savings are included, we can start making a benchmarking database of where we are as an industry from a carbon perspective. The last thing is just what we're seeing right now. So if I take concrete again, for instance, because it's the one where we've got the richest data in some places, what we're seeing right now is that by using the data and specifying low carbon mixes, requiring them or saying that they're going to get assessed, we're seeing about a 30% reduction from a baseline mix without a cost premium. So the cost has stayed the same on projects. The suppliers have done things like go to a different cement type, it gets a reduction, disclose their cement data, which gets a reduction, and then look at things like carbon cure for the last mile, and none of that has been a cost increase to the project. Again, the tool can help with this. So again, as we see comparisons, you can look at mixes with fly ash versus standard and see a reduction. You can then look at, okay, now I've got type 1L cement, what does that do? And then what does the future state look like? I project this as the future state, we'll see. Talking to suppliers, more than just concrete, but across industry, they are understanding this is important now and doing things to just invest in this to make their typical product a lower carbon product. So whether this is concrete or carpet, we're seeing the same kind of process in place. And with that, I'm at the end of my slides.
Thank you so much, Stacy. Can you hear me?
I can.
Great. Yeah, thank you so much. We do have a lot of questions coming in. Before we get to those questions, just real quick for everyone, for those of you looking for your continuing education credits, do stay on with us and then take that survey that pops up. If you missed the survey, check your spam from customer care at gotowebinar.com and you hopefully will find it there. And then for those of you watching this in the future on demand, not right now, take that quiz with an 80% passing rate. You can find the quiz on our Thinkific channel, on our USGBC channel, wherever you happen to be watching it. And before we get to all those questions coming in, a huge thanks to our board of directors, our volunteers, our new executive director, and our top tier sponsors, Mitsubishi Electric, Build Equinox, Serve2, and Rheem, ProTerra Prestige, Go All Electric, Go Net Zero Today. You know, there is a question here for those folks who are outside of the United States. I saw some maps where you've got some better data in Europe, some better data in the US. But I mean, really speaking, like, can people use this for projects globally, or is it currently limited to certain countries right now?
You can use it wherever the data exists. So we are pulling in the data from all the program operators globally. So International EPD is one of the large ones from Europe as an example, but they also have Australia. So we are constantly growing it. We now have the majority of their EPDs in the tool. We're working on Australia right now, for instance, but I know for Europe that we've got, you know, they have X thousand EPDs. We have X thousand EPDs from International EPD. So if there is data, we have it. I think the big hole right now largely is not finishes or even steel, it's concrete. And that's what we're trying to help fix from a concrete mix specific EPD perspective outside of the US. That's the one where right now, if you were going to use EC3, you'd probably just want to use the global collection of concretes to give you a range. You wouldn't be able to select your specific EPD right now. But we are very actively working with the concrete suppliers on a global scale to help with that.
So I'm just trying to wrap my brain around it. Then you can, if the product you're trying to use does not have an EPD, there's some sort of worst case average, or how does that work again?
Yeah, so if you can make the collection, that your search collection as broad or as specific as the data. So if you do a search for your product, you say let's do something simple like carpet. Do a search for carpet, you would probably likely find it right now. But if you didn't, from a product level, you then say, okay, does that manufacturer have a collection of EPDs I can use as my proxy? And if they don't, okay, can I use the US manufacturers of carpet as my proxy? And it will give you that current conservative 80th percentile of that, whatever that proxy is, as a starting point. So it's burden of the doubt. We're gonna be conservative with the number that you disclose until you can prove that you're better. And proving that you're better gets to more specific data from your product suppliers.
Someone here is pretty excited to see the pilot and draft categories you mentioned. How long until those are public?
That is our top priority right now. We're picking the top 10 with the most EPDs, things like paint, things like doors and hardware even, cladding, roofing. Will all be out hopefully in a matter of weeks. So what we've done is we were trying to get baselines established for all these categories before we publish them, but the data is becoming so rich that we're going to let the CLF take the time they need to figure those baselines out, but at least have the data out there for people to use very quickly, because it makes me sad when I do my demos with the pilot categories and I log into my public account and it's less categories. So we have a whole team working on that right now.
Awesome.
Yeah.
So what about those who are making negative carbon or negative embodied claims, such as some insulations like straw bale? I've heard of hemp. I'm sure I've heard bogus concrete ones before too. But how is that being looked at? Is that possible within the tool?
It is, yeah. So the closest we've got is with carpet with interface, where they've got a tile that is negative or almost negative. And it gets into how we account for the carbon sequestration or biogenic carbon and bio-based stuff. So it's a process to figure that out, but we are, as they come in, we are doing that. So we figured out what to do with that carpet, for instance. If we got straw, I would love to get some of those kind of bio-based materials in the tool. We would figure out the best way to account for that. And we can show below zero if we need to.
Right.
Yeah.
So, this is kind of a very specific prescriptive question, but, what if folks, obviously we always encourage performance over prescriptive, energy modeling, water modeling now, even air quality modeling to some degree. And this is another direction in that. But, just from a prescriptive standpoint, I mean, what kind of things are you seeing that people should just know, like, oh, you should just do this and you'll be headed in the right direction? Obviously, we want you to get in the tool and verify it. The specific question here is like, what if the concrete has fly ash in it? Does that reduce the embodied carbon?
Yeah, so for each material category, there's different kind of low-hanging fruit things that you can do. So for concrete, it's, how do you reduce cement? And to reduce cement, you do things like fly ash or slag or glass pozzolan. For steel, it's what kind of furnace are they using? Is it electric arc or blast? How much recycled content are they using in their steel? For other products, it largely comes down to each product also different, material categories different in terms of how important the energy, how much is actually in the energy grid of the plant and how much is in the extraction emissions of the supply chain materials.
Mhm.
So we do that analysis to help users understand that with the uncertainty. But for something like carpet, it's how much reuse materials are you using for your backing? What is that backing? Is it vinyl or is it bio-based? So recycled content comes into play a lot for a lot of these materials in terms of how much. It's kind of a circular economy approach. If we do the end of life well and put all that stuff back into the new materials, the emissions of those new materials go down too.
Right.
But that recycled content reuse part is big for a lot of categories. The Architecture 2030 has a great website called the Carbon Smart Materials Palette,
Mhm.
where they've gone through the top categories and done that exactly what we're just talking through. You could go to their website, it'll explain the emissions associated with a material category, and then here are the things that are the biggest impact reducers. So I'd highly recommend use EC3 for this kind of performance-based approach. Use that Carbon Smart Materials palette for the materials they include. And for other materials, you can kind of dig into it and start to see the trends.
Sure. Yeah, great. Thanks for that. I'll send that resource out too. So there is a follow-up on sort of the using the estimation, where at one point you said, okay, we don't have this information from the manufacturer, use US data. But their question is, well, should you first start, especially in a large country like the US, with a regional? So for example, you know, if it's a manufacturer in the Midwest, would we not look at Midwest data before we went to the entire country?
Yeah, exactly. And you can do that. So you can put in multiple states and create your
Oh,
own region.
oh, okay.
Yeah, so it's completely your choice how you kind of grow your sphere or radius of data. So you could start with Iowa and then expand it to all the states around Iowa. And if you still don't get anything, then expand even more broadly. So it's very user driven, but all the way down to the state level, you can do that kind of regional or regional search.
So, you know, wood costs are skyrocketing, or at least they were. Actually just saw an update as you were talking that maybe they're coming down. But anyway, it's gonna have ramifications that will echo for, I would assume, a very long time. And so we know wood as a potentially, some claim, negative carbon, or however you want to look at it. But I mean, I see people now looking at concrete and steel, which might have worse embodied carbon in them. And do you see some potential negative ramifications in the embodied energy space because of these wood pricing spikes, or what are your thoughts there?
Yeah, so generally speaking, we know that concrete and steel are higher emitting than wood. So if you know, can build out of wood, it's a good thing to do. The approach that we've taken with the tool is that we're never going to build everything out of wood, so we should be looking at all these materials to bring it all down, right?
Right.
It really is kind of category specific. So yeah, if there's a trend to move back towards concrete and steel, that is going to be a embodied carbon emissions uptick. If there's more buildings being built out of those materials, because obviously concrete and steel aren't down at wood yet. The range might be getting close, but we've got to get that whole thing down if they're going to be, you know, comparable in terms of emissions.
Right. So, you know, obviously when we're looking at designing our buildings or renovating them even, you know, we're looking at many factors, obviously cost. And now I guess we have to look at whether we can even get the product anymore, or how long we have to wait, which is unfortunate, and hopefully that doesn't last long. But setting those aside, from the environmental standpoint, you know, do you see in the future where you have a tool that can look at, you know, you're looking at insulation, not only are you looking at the embodied energy of the insulation, which is what you want to be doing, but of course your main concern is the R value. And then also health, you know, is this insulation going to off gas and harm my health? So do you see a unified tool ever coming where someone can just sit down and say, all right, here's the health impacts, here's the embodied energy impacts, here's the R value, and we're going to make the most informed decision from that?
Yeah, so I hope so. I think there's examples of where that data is starting to get assimilated. There's Mindful Materials and the Transparency Catalog, which are both open resources, where they're pulling in EPD data and health product declaration data, and whether it meets a LEED requirement and whether it's declared labeled, and giving you all of that in kind of one row. What we hope is that we're kind of in this lane of wanting to be the ones that provide the EPD data to everyone else. So I don't think building transparency would ever create that tool, but we already are pushing our data out to mindful materials and transparency catalog, and anyone else, it's an open API. Anyone can take our whole database and build it into another tool. So I think that there are folks looking at that, and we'll be the ones that hopefully people can point to get, the really good EPD data in one place.
Yeah, I heard you were potentially working with Passive House to.
Yeah, there's a tool, PH Ribbon, out of Australia, and I think they're doing a North American version through NAHPN. But yeah, they're pulling in our database into their tool for that upfront carbon component, and then building in the other stages and operational energy. There's also Cove tool using the data. So I think even on the operational versus embodied front, if we can provide the embodied data to those tools, then at least it's all aligned also. It's all the same data, so it's going to be harmonized no matter what tool you're using.
So we have a professor here who's very curious about additional educational resources for their students on EC3. Do you have anything like that for classrooms?
We don't have kind of a higher ed or even kind of an educational toolkit yet. We do have classes that are using the tool now, and some of their teaching, and they're gonna share what they're doing with us. So we're hoping to build some resources in terms of how classes are using it. We're doing things like just building projects. Every person in the class builds a project with a certain number of materials and shows how they can make choices and how they can lower the carbon content. So I think its use can be the same for a class as it is for a practitioner. And I'm more than happy. Our team will do trainings or get on a class to do a demo or work with a professor to help set up a program. Even how the students are registered and how things are shared. So reach out to me if that's something that's of interest, please. Yeah.
Yeah, great. And before we wrap up, I wanted to kind of go back to the LEED credits here real quick. And obviously you had mentioned I got the same one here. Yeah, so the LEED new construction or the commercial version of the rating system. And it's actually, I just learned, because we don't deal with it too much, that it looks like this credit is actually built right into the actual MR section under V4, and I suspect V4.1. So just remind us again, it looks like you've got to have that EPD already built into it. Do you also help handle option 2 within your tool?
So we are. So this one, not a lot of manufacturers have done this yet, but we're working with our materials can group, the group of manufacturers that are part of our program. And in that digital EPD, if someone wanted to know if a manufacturer met option 2, the manufacturer has a place to upload their documentation in the digital EPD and EC3. So if you go to the EPD, there you have the EPD to get the first point. You can see if that box is checked and that document is uploaded, and use EC3 to source manufacturers with that extra point. It's not gotten a lot of adoption to date. We just had a webinar for USGBC Live talking about how we're trying to get more of this. The tool will show you where a manufacturer is optimized. It's whether or not they've completed the requirements from the documentation standpoint to get the credit.
And so you actually have real projects that have been certified that have reported EC3 reports that have been accepted by GBCI?
I know there's at least some in for review. I don't know if I've heard anyone come back and tell me yes or no yet, but we worked with them to make sure that the graph and the chart that you can export for LEED is exactly the requirements that it asks for, even with links back to the EPDs.
Okay. Yeah, well, that would be great to hear, because I think a lot of folks look at this credit and their heads are kind of spinning a little bit, and myself as well.
Yeah, so there's actually there are 2 credits. So this one, all you have to do for this one is provide 20 EPDs. So that's where you can go to the tool and just say, okay, do my products have EPDs? Download and make a little folder of all those PDFs. The other credit is a pilot credit. It's called the low carbon procurement credit, and it's in pilot. And that's what we could actually, where you can use the graphs and charts to get those 2 innovation points. We're hoping that gets built into the construction credit portion of LEED as an actual credit in the next version.
Oh, okay, so that's a credit where you're actually getting your points, and here it is right here. I pulled it up while you were talking, where you're actually getting your points based on the actual reductions, correct?
Yeah, so 1 point just for disclosing. So if you put in your quantities and you just do the search collections, it will default to that, again, that conservative baseline, right? So you would just get a point for the fact that you did it. If you actually select EPDs and show a 30% plus reduction, you get a second point. And you can see there it's the same materials that are in the tool. So
Okay.
yeah.
Okay, interesting. Yeah, well, thank you for saying that. We always want to help people achieve their LEED. For those of you who are doing LEED for homes, this credit is not built in the official checklist, but it is an innovation credit. And I'm not sure if this one is, but I'm sure they would give it to us if we asked. So, and it's actually under LEED for homes. Everyone should just be aware that it's actually only worth 1 point. You can't get 2 points in there. So just letting everyone know that. So, well, I think, let's see here, if there were any other question here. So does Tally not also calculate the EC from material takeoffs? How does EC3 relate to this?
Yeah, so Tally does, it doesn't rely on product specific data. So there's a way that you can kind of proxy input an EPD into Tally, but Tally created that export function to EC3 because it was filling a gap in what they could do. So Tally, and we actually just acquired Tally. So Tally is a building transparency tool too that we're working to make free over the next year. But so Tally's using average emissions factors for those different products, product categories. EC3 is using actual product specific data when available. So what we found is that if you export a project from Tally with that average number, and then you look at the range of data that EC3 is showing you, Tally's numbers do typically fall right in the middle of that range of data that we're showing from the actual EPD collection. So it's kind of a do this and then transition to that right now. We're working on how we're going to kind of merge these things together now that we've got both tools under the same umbrella. So stay tuned for that too.
Well, Stacy, really appreciate your time and for joining us. Where can people go to find out information or contact you if they want to learn more?
Yeah, so it's on the screen, so buildingtransparency.org. You can email me directly. There's also a way to email, just contact us, and that goes to our entire team. If you're in the tool and you're a professional user, I didn't show this, but there's a little thing on the bottom right that's purple. It's called User Snap. You can actually even just click that, and on the screen that you're on, if you're having a question, you can type in what your question is. You can circle stuff and annotate it, and we'll go to our entire team, and we can email you back directly that way too. It's a tool question.
Great. Well, Stacy, thank you so much for joining us again. Thanks to Building Transparency. Go to buildingtransparency.org. Let's get those embodied energy, those upfront carbon emissions down immediately. Let's get to work. So thank you so much. Have a great rest of your week, everyone. Take care.
Thanks.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.